A lot of people use LINQ but are confused by exactly what is IEnumerable and what is IQueryable and what's the difference. When do I use which? I'm going to show you very quickly what the difference is, and it's much simpler than you think. IEnumerable is just an interface. It's not an implementation, it's just an interface. And many collection classes implement this interface. For example, here we have a list, just a list of integers. And if we go to the definition of a list, up here, we can see that it implements iList and iList of t. If we go to iList itself, we'll see that iList implements IEnumerable. So this shows that the simple generic list class can provide the IEnumerable interface. The purpose of this interface is to provide the simplest possible way of providing a sequence of objects. Now, most of the built-in collection classes provide this. Here's just some of them that I quickly looked up. List, dictionary, hash set, and so forth. All of them implement IEnumerable. And this is really important because LINQ to objects works off the IEnumerable interface. It expects that as the input. And therefore, all of these types of collection can act as the input to LINQ. Also, just a straightforward array, like an int array of numbers. An array is also something that exposes IEnumerable. So it also can act as a source, an input for LINQ to objects. The for each statement uses IEnumerable as the source of its objects. So numbers here is an array because array provides IEnumerable, therefore it can act as a source in the for each, and therefore so can all the other types of collection. LINQ to objects is based off the IEnumerable interface. Let's have a look at a couple of simple examples. So we take our numbers array and we can just get the interface that it provides. We can then see here that we can use one of the many different operations within LINQ to objects to add a where clause. So we're going to take this interface, add a where clause. In this case, we only want numbers greater than 2. And that itself, crucially, it returns the same interface. And this is really the power and the essence of LINQ to objects. Most of the operations take as input an IEnumerable, and they provide as output IEnumerable. As a result, you can daisy chain these together, you can link them together like a set of Lego blocks, and you can create any kind of length of data processing path. And this gives you tremendous flexibility and power. Now, this concept isn't new to LINQ, isn't new to C#. If you're familiar with computer science and you go to Wikipedia, you can look up something like list comprehensions. That's the computer science terminology for this kind of idea, and it's available in lots of different languages in various ways. Let's take another example. In this case, we're going to take the IEnumerable and do an order by. That takes a list and returns a list, in this case reordered. Now, not everything in LINQ to objects returns an IEnumerable. Some of them are just going to return a value. In this case, we're going to count the number of entries and give an integer the number of entries. Obviously, this terminates the processing pipeline because there's no longer a collection. We're now finished. We can optimize this. We don't have to keep taking the intermediate results. We can just take numbers and give it to where, order by, count, and then just produce the result in one line of code. Now, the implementation of LINQ to objects is actually inside this class, IEnumerable. We can look at that by going to the definition of where. And here we can see the IEnumerable class. And we'll see that there's lots of extension methods. We can see here, because it takes a this of IEnumerable, it's an extension method of this interface. And if we look at the right-hand side, it's going to take a predicate, because a where clause is like filtering the entries. So it's a predicate. For each item in the list, decide true or false whether we want to keep it or not. And there are many different functions like this in IEnumerable, where, order by. So if we come back, we now know how IEnumerable works in combination with the enumerable extension methods to provide LINQ to objects. IQueryable is an interface, and it's an interface exposed by LINQ providers. Each LINQ provider will take a source of data, will take a query that you provide it, and it will execute that query against the data and give you back the result. And the result will be an IEnumerable, a list of results. Let's have a look at the interface. If we go to the definition, we can see that IQueryable, because it can give back a list of results, does itself implement IEnumerable. But the real guts of it is inside IQueryable. Let's go to the definition of that. And we can see here the essence of an IQueryable. So the element type is what type of object is being processed within its list, within its data set. An expression, this is an expression tree, and it represents what query and operation you want to perform on the data of the query provider. And then the provider itself is just a reference to the internal query provider that's able to perform this operation. So we can actually take our numbers array, just a straightforward array of numbers, if you remember up here, and say turn it into a queryable. Then what we can say is we can take the existing IQueryable, add on an extra expression. In this case, we're doing the same as before, where v is greater than 2, and get back a new IQueryable. So we've extended the query in with a new query. We can then go on again, and this time we'll do the order by, just like we did before. And finally, let's get the count. The count will cause it to be executed, the query will be run, the list of items returned, and then it will count them and return the number. Now, here's the crucial difference. IEnumerable, if you remember, in LINQ to objects, is going to immediately do the where clause. The queryable doesn't take an actual predicate. And if we go to the definition, we can see that it actually takes, on the right-hand side, an expression tree of a predicate. So this is just a definition of the predicate rather than the predicate itself. The reason for this is that the query provider will examine this expression tree and decide what to do. If we take a simple example, Entity Framework is a query provider. If you take one of its DB sets, its tables of records, you can get an IQueryable from that DB set, and you can start doing things like we've done here, where, order by, group by, and so forth. When you execute that, it's up to the query provider from Entity Framework to decide, how am I going to do that? If you're using something like Entity Framework connecting to SQL Server, it's going to look at that expression tree and do a clever, complex conversion to turn it into a SQL, a select star from table, etc. And so it's only represented as a tree of an expression so that it can then examine it and decide what to do. Now, just as before, we don't usually take intermediate values to get the answer. We can just put it all on one line in order to execute that operation. In order to show some of the internals, I'm going to do a debug write line, and I'm going to show you the queryable one, and we'll look at the element type and the expression tree, and then we'll do the same again for queryable 2 and queryable 3. So let's run that. You can see here that the type of element going through the query is just integers, int32, and the expression tree starts out just providing the values from an array of integers. When we added on the where clause, the type of element is the same, it's still integers, but you can see that it has added on the where clause to the expression tree, and again in the last example it's also added on the order by clause. This is just an expression tree, just an object graph of what you would like. So to summarize, IEnumerable is the building block of LINQ and LINQ to objects. The enumerable class has all sorts of extension methods which provide the actual processing blocks for LINQ to objects. IQueryable is what is exposed by LINQ providers such as the Entity Framework in order to allow you to perform operations against sets of data. How those operations are performed is very specific to the query provider. Something like Entity Framework will turn it into a SQL query to be executed against a database engine, and then you get back the result. Different LINQ providers will do something completely different. Hopefully you found that useful. If so, hit the like button, and until next time, happy coding.